Hey guys, welcome. Yeah, so example 10 here, and a really fun problem. And the equation that we have to solve is as written here. And the first part of what I'm going to do here on this board might seem like it has nothing to do with solving this equation, but it has everything to do with solving this equation. So just be patient, and let's start with this, which is, I recall that sine of alpha minus beta is equal to it's equal to sine alpha cosine beta, and then it's minus sine beta cosine alpha. And I write this because we need it to do the following, which is we're going to use it to write sine of pi over 4 minus pi over 6. So I'm saying alpha is pi over 4 and beta is pi over 6. And this clearly is sine of pi over 12. Pi over 4 minus pi over 6 is 45 minus 30, which is 15. So we're trying to find sine of 15. All right, and so that's going to say sine pi over 4, right? And then cosine, I'm just using this equation, cosine pi over 6, and then minus sine of pi over 6 times cosine of pi over 4. Now, I hope you know your 30, 60, 90 and 45, 45, 90 degree triangles. So here I can say that sine of pi over 12, which is this here, is equal to, what's sine of pi over 4? Root 2 over 2. Cosine of pi over 6, that's root 3 over 2. Okay? And that's a times, and then minus sine of pi over 6 is 1/2. Cosine of pi over 4, just like sine of pi over 4, is root 2 over 2. So we have here that sine of pi over 12 is equal to, what does this simplify to? Root 6 over 4 minus root 2 over 4. And I could just write it here, and therefore root 6 minus root 2 all over 4. Yeah? Okay, cool. And then next on to cosine of alpha minus beta, which is cosine alpha cosine beta, and then plus sine alpha sine beta, that's an alpha, it's small though, sine alpha sine beta. And I prove one of these angle addition subtraction formulas, and if there's a demand for it, then I'll prove more of them. But yeah, like the proofs are very similar, so if you see one, then the rest of them are kind of anticlimactic. Okay, so I wanted to do this because, well, I wanted to use it to find cosine of pi over 12, which again we write as pi over 4 minus cosine of pi over 4 minus pi over 6, right? So cosine of pi over 12 here. And using the right hand side, this is right? And cosine of pi over 4 we've already done. Cosine of pi over 6 also we already did. And it was, what was cosine of pi over 6? It was root 3 over 2, right? And then we have plus root 2 over 2 for sine of pi over 4, and sine pi over 6 is 1/2. And what does this simplify to? And this is cosine of pi over 12 as a gentle reminder. This is root 6 over 4 plus root 2 over 4, and therefore root 6 plus root 2 all over 4. So now, knowing this is equal to this and this is equal to this is instrumental in solving the equation on the left, which is why I did all of this legwork. Let's box these two. Alright, so let's come back to this equation here on the left. So what does that got to do with this? Well, the first thing we'll do in this equation is divide both sides by 4. And so I could write that as like times a quarter, or 1 over 4 on the left, and just get rid of this 4 on the right, right? I divided by 4. So when I do, I could view the left side as being root 3 minus 1 all over 4, and then in turn all that divided by sine x. If I so chose, I can see it like this, right? And then we have plus, and this part we're going to get root 3 plus 1 all over 4, and then all over cos x, right? Equals root 2. All right? And the next thing I'm going to do is I'm going to multiply both sides of this equation by root 2. You see why I want to do that? Well, if I multiply both sides by root 2, on the left side, it amounts to multiplying this numerator by root 2, and in particular, multiplying by root 2 over 1 in the numerator, right? And so I distribute this root 2 here, here, and then here, and there. And when I do, look at what we're going to get. We're going to get, in this part, we're going to get root 6, exciting, right? Minus root 2, all over 4, and then all of that divided by sine x, right? And then we get plus, and this part we're going to get root 2 times root 3 is again root 6, plus root 2 all over 4, and all of this divided by cos x. Now you see the method to the madness. Now these two guys multiply to 2, right? Okay, so what is this here? Root 6 minus root 2 all over 4. We wrote it. It's sine of pi over 12. So I can replace this here with sine of pi over 12. I'll do that right now. So I have sine of pi over 12. And what's this here? That's that fellow right there. And that's cosine of pi over 12. Okay, so I can replace this with cosine of pi over 12. Right? And then now, looking at what we've got, what should I do? Clear the denominator on the left side. And to do that, I multiply both sides of this equation by sine x times cosine x. When I do in this part, when I multiply by sine x times cosine x, if signs will cancel, I'll get sine of pi over 12 times cos x, right? So I'll have cos x times sine of pi over 12, and I could get rid of this. And again, I did that. I got this by multiplying by sine x times cosine x on both sides of the equation. I'm not done, obviously. And in this part, let me scoot this too. In this part, what am I going to get? When I multiply this part by sine x times cosine x, this time the cosines will cancel, and I'll get cos pi over 12 times sine x, right? And clearly on the right side, I'll get 2 times sine x times cosine x. But we reckon that this is sine 2x using the sine double angle formula. 2 times sine x cos x is sine 2x, right? Okay? Furthermore, we notice that this is equal to sine of pi over 12 plus x using the sine angle addition formula, right? So we have this is equal to sine 2x. And then we realize that this is true only if pi over 12 plus x is equal to 2x, or because we know that the sine of an angle in the first quadrant is the same as the sine of pi minus that angle in the second quadrant, because sine is positive in the first and second quadrant. We also see that we can come up with this other equation, which is pi over 12 plus x is equal to pi minus 2x, right? And this is easy enough to solve. We subtract x from both sides and reckon that x has got to be equal to pi over 12, right? And for this fella, we add 2x to both sides, so I get a 3x, and then subtract pi over 12 from both sides. Remembering that pi can be written as 12 pi over 12, we see that this is going to reduce to 3x is equal to 12 pi over 12 minus pi over 12 is going to be 11 pi over 12. And then dividing both sides of this by 3, both sides of this equation, we see that the other answer is x is equal to 11 pi over 36. Both this fella and this fella fit in the interval that we're given, and therefore we're done. I hope you enjoyed this, and yeah, I thought it was as fun as I thought it was. Otherwise, take care.